All right, this is Mr. Gillum, and today we're going to start learning about congruent triangles. So basically we're going to learn how to write a valid congruent statement, and tomorrow we're going to get into some proofs, which I know you love, so we're going to get into it. To be congruent, figures must have the exact same size and shape, or shape and size. And what I mean by shape and size is I mean they need to have the exact same segment lengths and angle measures. Okay, only rigid transformations. So now if you remember back, we talked about rigid transformations towards the beginning of the year. Rigid transformations are things that don't stretch or compress the shape or the polygon in this case. So a reflection is okay, a transformation, or I mean translation is okay. A rotation would be fine. However, if you start making it bigger or smaller, even though the angles may stay the same size, the shape is changing size, and that's not a good thing. So only rigid transformations are allowed. Must be rigid. Okay, so you can see the difference here between congruent and not congruent. This is the exact same shape in all three figures, same exact size, same exact everything. However, you can see that number 4 is much bigger than 5, and 5 and 6 look exactly the same, but the problem is that angle, or number 4 is not the right one. It's not the same size and shape. So it's got to be exactly the same. It can be twisted, rotated, reflected, but it must be exactly the same to be congruent. So let's take a look here. We need to write a congruent statement for this little fellow right here. So I have these two triangles, ABC and KHJ, and what we need to do is we need to make sure that we're listing the corresponding vertices in the same order. So what that means is, what I mean for it to mean is this. If I look at the sides with the 1 dash on them, the AB and the HJ, as I'm writing this, okay, these triangles to be congruent to one another, what needs to happen is, if I start my triangle as A, B, C, I need to make sure that as I'm writing my congruent statement, that if AB is first here, the part that's congruent to AB is first in the next triangle. So in this case, HJ. Okay, and then I'm going to look at the BC part. Those are my next two letters. And in this case, BC has the 2 dashes on it, and in this case, that would be the JK. So BC would go with JK. So I'd write it just like that. Okay, so this would be a valid congruent statement. Okay, and then finally CA and KH should match as well. CA and KH, and they do. They both have the three dashes to indicate that they are the same length. And so as you can see, not only are each segment AB and HJ the same, BC and JK, CA and KH, but also the angle should be lined up exactly the same. So let's look at angle A right here with the 2 dashes, and angle H should also have 2 dashes. Okay, B should have 1 and J should have 1, which they do. And finally C should have 3 and K should have 3. And it does. So this would be an example of a valid congruent statement. The order of the letters does matter. Okay, we want our segments to match up, so you can tell just by looking at this congruent statement which parts are actually congruent. Okay, so a non-valid, I don't know why I would say non-valid. An invalid, of course, invalid congruent statement will be something like this. And we do actually, when we're labeling our triangle, we need to go in the same order. If I said that triangle ABC was congruent to triangle HKJ, then we're going to have issues, because if we look at this thing, A and H, A has 2, H has 2, so far so good. B and K, B has 1, but K has 3. So this would be an invalid congruent statement. So just make sure that when you're writing your congruent statements that all the segments and all the the angles will line up so where you can look just at the congruent statement and know which parts are equal. It's going to be very important for us. Now, as we're looking at these congruent polygons, what we need to do is we need to show they're congruent by identifying all the corresponding congruent angles and their corresponding sides, because in order for them to be actually congruent, they need to have the exact same segments and the exact same angles. So let's take a look here. First, let's identify the angles. And so to identify the angles, and we've seen these notations before, one arc and one arc will go together. So we could say angle P, that's really skinny. Let's do this. Angle P, oh, too much. That's the one we want. Angle P is congruent to 1 dash G. Angle G. And then we can look at our two dashers, Q and F. And then we can look at our three dashers, R and E. Well, R is congruent to angle E. And finally, our four dashers, 1, 2, 3, 4, 1, 2, 3, 4. Angle S is congruent to angle D. Okay, now our sides, same idea. The dashes indicate that they're of equal length. So let's go right in order. Let's do PQ and GF. They both have 1 dash. So we can know that PQ is congruent to GF. We would also know that the two dashers, PS, is congruent to DG. And we talked about this notation as well. I don't need the segment lines above. I accidentally did the first one. I didn't feel like erasing it. So we can just make it all uniform. It's understood that if the two letters are next to each other, we're indicating a segment length. Then we have our three dashes, DE. Oh, you know what? I'm going to make sure I write them all in the same order. So I'm looking at the three dashes and the three dashes, SR. And it's congruent to DE. And finally, that leaves us with QR and EF. Okay, so now the fun part. We're going to write a congruent statement. We need to make sure that all the segment lengths go in order and the angles match up as well. So what I'm going to do is I'm going to go right around from in this guy, P, Q, R, S. I'm going to go right in order. I'm going to kind of ignore the second quadrilateral right now. I'm going to say P, Q, R, S is congruent to. And so now it should be a little easier for me to write my congruent statement here because I know P and G need to line up. So I'm going to say G first. So they both have 1. And then I want Q. I know that goes with F. So G, F. R goes with E, E, and S goes with D. Now let's just double check to make sure this is a valid congruent statement. Is PQ and GF the same? Yes, they are. QR and FE, where's that one at? Okay, that worked out. RS and ED, RS and ED. Yep, right there. And then finally SP and DG. SP and DG. So having these on our paper here for the first view is going to be important because we need to make sure that our angles line up as well as our congruent segments. So let's take a look at this last little part here. Let's throw a little algebra in the mix, and basically if you have a good congruent statement, like in this case it gives you the congruent statement, it should be relatively easy to find the values of x and y. So what I'm going to do is I'm going to go ahead and mark on my diagram right here. It says RS and TV should be equal. So I know RS is right here and TV is right here. So I'm going to mark 1 dash on them. It also tells me that SV and VS are equal. Well, that makes sense because they're the same exact segment. That's the triangle that they share, or the side that they share of the triangle. And now I know that VR and ST are the same. VR, I'm going to put 2 dashes on him, and ST are the same. Okay, so now let's use this information to figure out what we're doing here. The first thing I know is I can find on this side length here, and this side length are the same. I know that 2y minus 1 must equal 24. 2y minus 1 equals 24. So I'm going to add 1, 2y equals 25 and divide by 2. Y equals 12.5. I prefer the improper fraction. That's just fine. Y equals 25 halves. And it just says find the values of x and y. It doesn't say find the side length. That's fine. So I found the value of y. I still need to find the value of x. So now, it tells me that x is angle t. So if I look back here at my congruent statement, t, I'm looking at angle r is what I know must be equal to. The problem is I don't know angle r, but I do know that triangles add up to 180 degrees. So this guy right here must be 180. I have 90 for my right angle. I have an additional 78. So total I have 168, leaving just 12 degrees for angle R. And so if angle T in my congruent statement is equal to angle R, and I know angle R is 12, then I know that X must equal 12. Okay? So basically what we're going to be doing is identifying these congruent shapes. There must be a rigid motion. If it changes size, it's no longer a congruent shape. And that's it for today.